Imagine we traveled back 300 million years to the Carboniferous period. It's a world of massive swamps, heavy humidity, and giant ferns. But if you look up at the trees, you might see a huge shadow streak past, something massive and incredibly fast. The real secret to this world was the air. Back then, endless forests of giant trees were pumping out so much oxygen that the atmosphere was basically supercharged. Oxygen levels were at a massive 35% compared to just 21% today. This thick oxygen actually changed how the horizon looked, giving the sky a weird sepia tint. But it was also dangerous. The air was so explosive that a single lightning strike could set entire continents of forest on fire. In this era, monster firestorms were just a part of daily life. The king of this volatile sky was the Meganeura. With a wingspan over 25 inches, it looked like a modern dragonfly but was the size of a hawk. Before birds or flying reptiles even existed, these insects were the undisputed masters of the sky because the atmosphere had literally lifted the size limit on their bodies. You see, insects don't have lungs like we do. They breathe through a network of tracheal tubes that pump air directly to their tissues. Usually, there's a physical limit to this. If an insect gets too big, those tubes take up so much room there's no space left for muscles or organs. But the Carboniferous air fixed that. Because the air was so rich, Meganeura needed fewer tubes, leaving plenty of room for huge flight muscles. These things could cruise at 40 miles per hour and had to eat their own body weight every 30 minutes just to keep going. With 360-degree vision, they were the ultimate hunting machines. Basically, Meganeura was an evolutionary masterpiece that only worked because the atmosphere was providing the high-octane fuel it needed to run. Decades later, scientists at the Argonne National Laboratory used a massive particle accelerator to see how this worked in real time. They found that insects don't just let air drift in, they actually use their muscles to pump it, a move that's incredibly easy when oxygen is high. But around 290 million years ago, everything changed. A new type of fungus evolved that could finally break down dead wood. Instead of that wood turning into coal, it started to rot, releasing carbon and causing oxygen levels to crash. The world's climate went haywire. Swamps dried up and turned into deserts. The clues in the rocks all point to one thing. The Earth's life-giving gas was running out. As the air thinned, the giant insects lost their biggest biological advantage. While the insects were struggling, a new class of predators, vertebrates, started moving into the canopy. Early reptiles like Coelurosauravus grew wing-like membranes from their ribs, gliding through the air to snatch up the small bugs Meganeura needed for food. Then came the feathered dinosaurs like the pigeon-sized Anchiornis. Unlike Meganeura, who had big, rigid wings that couldn't fold, these new hunters were agile. They could maneuver through tight branches and bring the fight directly into the trees. Meganeura was now in a double bind. The thin air made flying exhausting, and these new warm-blooded predators were intercepting their prey mid-air. The final blow landed in the Jurassic with the first birds. Archaeopteryx had the energy efficiency and the claws to simply outcompete and outhunt the old, rigid insects. But the real silent killer didn't show up until the Cretaceous. About 125 million years ago, the first flowering plants appeared. When their petals fell into the water and rotted, microorganisms ate up all the oxygen in the ponds, suffocating the dragonfly larvae living at the bottom. So the giants weren't wiped out by one big explosion. They were slowly erased by a changing world that took away their air, their food, and finally, their nurseries. Those hawk-sized monsters are long gone, but their legacy lives on in the small, zippy dragonflies we see at ponds today. The few large insects left are hidden in deep jungles, and now they face a new threat, human-driven habitat loss. When you see a modern dragonfly resting on a blade of grass, you're looking at the echo of a lost empire. The story of Meganeura proves that being the boss isn't permanent, it's just a temporary lease that nature can cancel the moment the rules of the game change.